Hello, everyone. Welcome to today's webinar. My name is Erin. I'm the Business Development Manager here at Softree, as well as one of our resident webinar hosts. Um, so our webinar today really is going to be focused on core concepts and an introductory workflow for road design using LiDAR data. Of course, the webinar is going to be done using RoadEng software, and if you're not too familiar with it, or if you're checking out a webinar with us for the first time, RoadEng is an easy-to-use road and site design software. It's built specifically for rural and low-volume roads, and I'm a little bit biased, but I think it's quite great at dealing with long roads and dealing with large LiDAR data sets, and large data sets in general. So I'm going to do a little bit of a brief introduction here, talk us through a workflow, and then I'm going to pass it over to my colleague Matt, who's our resident webinar demonstration expert, and he's going to take us in the software. So to start, RoadEng is modular. We've got two core modules in the software that we're going to leverage today. The first is the terrain module. And in the terrain module, this is the place where we import our survey data. So this is where we're going to bring in our LiDAR. We also have an optional step. Depending on the size of your data, this is where we can selectively thin it and import an area of interest. So we're going to do that. That keeps our model a little bit lighter and working quite quickly. From there, we're going to create a tin surface model. A tin surface model is an essential step that can't be skipped when going and creating a road design. So this tin model, which stands for Triangular Irregular Network, is going to represent our original ground. The final step in order to get over and doing a road design and out of the terrain module, the mandatory step is to then save that tin surface model as our native terrain format, which is a terex file. So we're going to save it as a terrain file, and then we're going to move over to the next module. Now there's a few additional steps that we can complete at this point in time. We could also leverage our hydrology tools. We could add a background ortho image, or we could even add another terrain file for additional context, whether that is a site design that's included, or even additional shape files for reference. Lots of options of things we could do in addition. But today, really just focusing on showing you how to import the data, thin the data, create the tin model, and save it to move to location. So from there, we're going to head to our second core module, which is the location module. Location is really specialized exclusively for the design of linear infrastructure. So that could be roads, pipelines, railroads, you name it, stream projects. We do all of those within location. And I feel like actually this might be a good opportunity to just say today's project is sort of a generic resource road. As I recognize, we've got an awful lot of different industries represented in our audience, as well as countries. So just welcome everyone. And yeah, we've got forestry folks, mining. I saw some renewables in there, departments of transportation, local government transportation, as well as our civil consultants. So today's project really is going to be sort of a generic road. It could be any one of your types of projects potentially. So anyways, that was my little disclaimer. So back to our steps in the location module. We're going to create a new location design, and that is going to be based on our terrain file. So we're going to reference that when we start. In location, we're actually not pressing file open to find our terrain file. It is file new. We're going to reference that, that original ground surface that we created in the terrain module here. And then we're going to go through our core road design steps, defining our cross-section, so either adjusting it or creating a new one in our template editor, creating our horizontal alignment, adding curves, creating our vertical alignment, adding curves, as well as I think Matt's doing this today, which is why I've got it up on the slide, but we're going to leverage Softree Optimal. It's sort of a it's our earthwork optimization tool, but it can really speed up that vertical alignment creation process. So we're going to leverage that, And then from there, of course, there's the iteration and the fine-tuning of design, labels, earthwork balancing, getting your mass haul right, ground types. There's a ton of elements that could fall into that iteration and fine-tuning. From there, we're going to go ahead and add a couple of culverts and drainage structures to the design. And then probably one of the most important steps is the output. So creating output sheets for construction and for communication of the project. Now, one last important thing, and we are going to be doing something special. We didn't announce it because we weren't quite sure if it would be ready, but end of today's webinar, we are going to be giving you a sneak preview of some I'm really excited about it, really exciting version 11 functionality. We are going to be bringing in something called Path Explorer to the software. And with Path Explorer, and this is my little tiny photo example, we are going to be solving the problem of how do we go from A to B and getting the software to find routes. So we're going to be including this at the demonstration of this at the end of our presentation. So stay tuned right till the end for that. And with that, Matt, are you with me?
I am.
Awesome. I'm going to make you the presenter.
Excellent. I'll share my screen and I'll just briefly turn my camera on here to say hello. So.
Awesome, and I'm going to turn my camera off and let you take over.
All right, perfect. Yeah, so I'm going to do the in-software side of the presentation, and as Aaron introduced, we're going to start out in terrain. So this module here, and we're going to use that to build our topo surface, and then we're going to switch over and do our design and location. So I'm going to turn my camera off just because I'm going to be looking at another screen for most of this, and we'll dive into it. All right, so I'm going to open terrain, and there's going to be a couple points along the way here where I cheat, and instead of watching the computer think, I'm going to insert or jump ahead to avoid that. So I've opened terrain, and to start, well, if I want a little context of where we're working, I can bring in some other spatial data aside from just the data that I want to use to model my surface. So to start, let's bring in these 2-point files, or single file with 2 points in them. So that's a shape file, and I'm just going to change my symbology here to make it so we can see what we have going on. So I've got 2 points. I can add more information, so I'll bring in this area of interest file. So this is just a polygon, and again, this is optional stuff, but I am going to use the feature from this here in a moment. And then next, we'll bring in our LiDAR data. So I'm going to click Insert File, and I'm going to grab my LAZ files in this case. Now we could grab LAS files, we could grab DEM data. I'm going to grab all of these. Now I don't need all of these, and they're fairly data heavy. So rather than sorting through what files I need and maybe bringing in a bunch of extra data that just weigh things down more than we have to, I am going to do this selective thinning on import. So from here, the LAZ, I want to use my ground points. I'll click the selection tab, and I'm going to add a region for thinning. So I'm going to go add. I could thin based off a corridor if I had a polyline I'd like to use. I'll use a polygon, and I'll select that AOI shapefile feature. So within that filter region, I'm not going to skip any of the points. But outside of that region, I'm going to tell it to skip everything. So this way, I'm not bringing in a bunch of data that has no benefit to my project. And here's where I cheat. So if I hit OK, it's going to take a moment to plug through there. I've got about 3 gigs of data. So rather than just watching my computer sort through what points we'd like, and I think it takes about 3 minutes in this example, I'm going to hit cancel. I'm just going to jump ahead to this file. So if we had hit OK and waited the 3 minutes for that to decide what we should bring in, we would get something like this. So here, all of my LiDAR data is selected. So it's being displayed in pink. And the property for those features is the display property is turned off. So I can see them when they're selected, but if I click off to the side, they deselect. I can still see I've got about 5 million points in my model down here. So the next thing that I'll want to do is take this large collection of points and turn it into a tin surface. I'll go up to the top here. I'll click Terrain Modeling, and I'll click Generate, and I can create my tin. Now the tin will generate fairly quickly, a matter of seconds, and then I can generate contours as well. And here's a case where, again, to not watch my computer think for a minute or so, I'm going to cheat and hit cancel. But if I hit OK, it would build the tin really quickly and then take a minute or so to generate my contours. And the outcome is something that looks like that. So this is my terrain file, and there is a tin in it. So this is the surface, and I want to use this to do my road design. So I'd hit File, Save As. Now I've already saved it, so I'm not going to save it again. But this is the file that I'll use when I jump over into location to do my design. So let's minimize that, minimize all these other ones that I have on the go, and we'll open up location. So Aaron emphasized it, and I'll emphasize again. So we're creating a new location file. If we had a location file that we wanted to open, we'd hit open, but we don't have a location file. We want to create a new location file that references our topo surface that we've just created. So we're going to click this green icon up here, and rather than clicking open, we're going to click new file. We're going to reference that file that we're working with. We'll click open. We'll click OK. And it's taking a moment to read that in. And then we can choose what we'd like to use for our initial alignment. So if we had a polyline we'd like to use from that terrain file, we could use that. If we had a hand traverse file, we could use that for our initial alignment. If we had a land XML file, we could use that. I'm going to start with a single point, and I'll go with the current features or current point selected in terrain, but we could go with the center of terrain or a specific coordinate if we'd like to as well. And we'll use our default template, and this is the default screen folks will see when they first install RoadEng. Now, with this, we can see this is my plan view. So that's kind of the bird's eye view of my project. I've got my cross-section view here. I've got a data table here. I've got a couple buttons here at the bottom that I can do things like open a panel. So I've clicked my Culverts panel. And then I've got other panels over here that are docked off to the right. And at the top I have my ribbon with various functions in each ribbon. So as folks use the software, they usually develop a preference for what they see and what they consider while they design, and I am also in that boat. And for me, I like my screen to look a little different. So I'm going to change my screen layout to be this. Now, if I had have saved it as normal.dlt in that default directory, it would have been what's there when it opens. But and it usually is for me, but I decided to show what a new install would look like. So with this, the ribbons, the buttons are the same. I've got another panel open on the right, and then in addition to my cross-section view and plan view, I have my 3D view and my profile view. And in my profile, I have my mass haul. Before I get into the actual design things, I'm going to do one optional thing, and that is I'm going to set my 3D view up to look the way I like to see it. So rather than just seeing my contours for that topo surface, I'm going to right-click in here, click 3D options. I can choose which surface I'd like to edit. So I'll go with, there's only one showing there now. I'll select that. I don't want to see my features. I do want to see the triangles. I want those triangles shaded. And I'd like it to be transparent. So if I'm building my road and cut, I can still see the road underneath the topo surface. And as we design here, it's not going to show anything now because my road's just a single point, but as we design, I'd like to see my road as a surface too. So I'm going to click that. I'm going to click that. So I'm going to add a corridor surface, and here I've just got one alignment in my design so far. I'll change the color so it's easy to see. I'll hit OK. And I'll hit OK. And there's our 3D view. So I've got kind of the optional stuff taken care of. And let's tackle our first design consideration. So before I start messing around with my alignment, I'm probably going to want to make sure my cross-section geometry is appropriate. You don't have to. You can do this after the fact, but we'll do it now, and then we'll have a better idea of what we're designing and how we're interacting with the surrounding terrain as we model that road. So our cross-section geometry is displayed here, but the dimensions and if there's any logic in those templates, it's set up in our template editor. So here I can see I've got 3 templates that come default with the software. So this shows me one with a pavement structure, a base, sub-base. I want to use this. So just a simple gravel road. If I'd like to, I can click properties and I can change some parameters at the template level, but most of the properties here are in the component level. And it's really easy to change them and see how things affect. So if I want to change this from being an 8 meter wide surface to, let's say, a 5 meter wide road, I'll change the width on one side to be 2.5. And we can see it updates in real time in front of us. Now I'll hit cancel and we'll use this, but just a side note, these are really modular, and if you want to build new templates that deviate quite a bit from what's displayed here, you can use the library to have the building blocks to put together into a template rather than having to build these from scratch. So I haven't changed anything there, I just talked about it. I'm going to hit cancel. The template that's applied is still the one with the pavement. So let's go into assign by range and we're going to change which template is being assigned. So the one we want to use is this RES, resource low volume. We'll apply that from station to station. So we can use different cross-section geometries along the length of our road. But for this, I think we're just going to use a single template the whole way. So we'll just assign it from dot dot to dot dot, which covers our whole extents. And there we are. So next we can get into the kind of more of the geometry solving side of things. So I've got my initial point right there. I'm going to right click in my plan view. I'm going to click add edit IP tool, and I'm going to start clicking in my horizontal alignment. And as I do that, we can see that my profile is updated here in real time. And in case anyone's not familiar with what I'm referring to as the profile on the left here, it's showing me along the x-axis my road stationing, so the length of my road, and then on the y-axis is the elevation. So it's the longitudinal section of our road. So I'm going to continue along here. And as I do this, I'm not going to get too bent out of shape on the details, but I am going to pay attention to general behavior. So I'm going to just like I was doing in the plan view, I'm going to have add edit IP tool selected in the profile, and I'm going to click that in, and we can see I have a grade turned on here. So that's at 7%. Now my scale is locked. If I unlock that scale, so right now my scale is horizontal scale of 1 to 2,000. If I zoom in and out, that scale stays the same, and my view is being magnified. If I unlock the scale, my line types get bigger as I zoom out, and the scale is dynamic. So that's the lock scale there. So I'm going to unlock that just so I can be zoomed way out and see, okay, I'm at 14% there. And for this project, I'm going to try and keep things under 15%. So I'll continue along here. I can see, okay, at that point, I'm flattening out. I'm going to move this point, and where I'd like to go to is up on that ridge. So I'm going to move that point, and I'm going to try and keep climbing without exceeding my max grade. So it's a 3D problem. We won't think of just the horizontal or just the vertical. And let's go there. And this is something that all that new feature that Aaron introduced certainly will be easier in the future, but for now it is just a little bit of clicking to kind of visualize where we'd like to go and how we're going to interact with things. So here I can, again, I want to keep climbing. So it's all dynamic, and one view is connected to another. And we're reaching that bench there, so I'm going to keep going up. And on this project, I've got my little dot where I'd like to go showing up there, so I'm going to just pan this around and we can see. So I'd like to come up here and maybe snake through that ridge. Now another thing that I'm largely ignoring at this point is my mass haul diagram. So that's keeping track of my material surplus and deficits. So how much extra or how much too much material I'm digging up and not using as fill. And the reason I'm not getting too bent out of shape on that so far is I'm largely ignoring curves. So we aren't going to ignore curves the whole time. I'd just like to get to where I'd like to go. So I'm looking at that. I don't see any obvious issues. Of course, I've got a really big cut there, but we'll iron that out here in a moment. I've got a massive fill there as well. So I'm just going to click there and see where am I at. And this scale is locked as well. So if I turn that off, we can see my cursor's right around there, and maybe it makes sense to pull that into the hillside. And we can see, so not just my profile and plan and cross-section showing up in real time, my 3D is as well. Now I'm going to add some curves. So I'm going to click my cursor there. So I'm on my horizontal curves panel. I want to add a circular curve. I'm going to shoot for a 50 km/h road. So I'll set my radius to be 100 meters. I'll hit apply. And there we are. There's my curve. So it's that dynamic interactivity. And by adding a curve, we're changing the position of our road and changing the length as well. So cutting that corner off to smooth things out. So if we wanted to, we could change that to whatever radius we'd like. And we're not stuck with it either. So if I was happy with it there, I could leave it there, or I can grab that and maybe pull it in. So I'm grabbing my IP to move it. Now we could cycle back and we could add a curve here. So we can do that manually. And we can go back and do that again. Now here, and I've already done it, but if I make changes to my curve parameters, I could set this default curve, and then instead of adding all these horizontal curves in manually, I can click this button. I can say, well, let's apply our default curve anywhere it fits. We'll hit OK. And now all these IPs are going to have that 100-meter radius curve that I'd like to use for my minimum curve. And if it doesn't fit, like that point, and I guess those are the only spots, it just doesn't apply it. But I can really quickly say, well, there's no curve there. Let's either come in here and maybe we can assign a smaller curve to reduce our design speed, or maybe it makes sense just to move this out, realign what we're working with a little bit, and apply the curve after we've realigned it so our end of our previous curve isn't overlapping with where the beginning of that 100-meter radius curve would have to be. So let's do the same over here. And I think we can move things around to get it to fit. And we can. And we can see here my little dashed green line, that's my slope stakes. So I can see I'm filling out even without looking at my 3D view. Perhaps I want to make some adjustments so we don't end up spending a fortune on fill material. Better, not ideal, but I can also drop my grade. So we've got our horizontal curves in there, and it is an iterative process, so there may be some going back and forth between my plan and profile as I make some adjustments. But I can come in here and use my vertical curves panel to adjust those curves. So I'll go with a K of 11, so a crest of 11. And we can see what we're working with there. And here, well, I'm through cutting through that awful hillside, and it would be nice if we just avoid it. So I'm going to right click again, that iterative, let's make better decisions because we can see what's going on. Let's just move that out. So rather than going through that little ridge, let's pull this out a bit. Pull it in. And we'll add a vertical or a horizontal curve at that location. So now that I think I've got it kind of close, if I were designing this entirely by hand, I'd go through and I'd start adding those curves, and I'd try to keep my mass haul as close to zero as possible. I'd keep in mind the direction of my material movement and try to minimize any surpluses. It can be a tedious job, and oftentimes, even if you're careful, you won't you might leave money on the table from a construction standpoint. So Aaron introduced that I use the easy button here, and I totally am. I'm rather than doing my vertical by hand and making these really fine adjustments, I'm going to do an optimization. And just so this doesn't look too funny, I'm going to change my scale back. All right, so to do this optimization, I'm going to expand my Project Explorer. I'm going to go into my vertical. I'm going to click vertical options. I'm just going to tell it to sample along the length of my road. I'm going to allow it to have curves butted right up against each other. So fast curves, it'll be the cheapest option, but it will be fairly humpy bumpy. And I'll come in here and I'll say, well, I want to have my start of my alignment right at where it currently is. And then we'll come over here and we'll click vertical optimization, click process, and it's going to run through. And the first thing that it's going to do is sample. And then the solve for this should be fairly quickly, or should be fairly quick. And we'll take a peek at our balanced mass haul and well, the cheapest vertical solution. So with that, we have a few minutes.
Yeah, and Matt, I was actually going to maybe see if you could cover one PowerPoint slide I did not cover, which is probably one of our most commonly asked questions, which is basically what format of LiDAR data should I be working with? We're often asked if it's better to bring it in an LAS format or LAZ format, or to bring in sort of one of those LiDAR derived products like a DEM in geotif or other formats. So perhaps I've got a bit of a slide up here. Maybe you mind presenting it for me?
Yes, absolutely. So I will apologize, just looking at this on someone else's screen, it's harder to see than mine when we put the images together. But on the left, bottom left on the plan view there, you can see we have these cluster of little magenta points. And there's areas where the points are really close together and areas where they're really far apart. On the right, bottom right, we can see that those points are just on a regular grid. So the difference is the LAS files are the actual points that the scanner collects when they're scanning an area. And the DEM data is a derivative of that. So in order to get to a DEM, when it's being processed, they'll take the LAS files, create a tin, and then they'll grid them. And we see the points that are set on that regular grid are showing up. So for us, it doesn't make really any difference whatsoever. It comes down to personal preference and what the requirements are for your job, as well as how you have access to them. So one thing where it may matter is if you have something that's really critical where you want as much detail as possible, well then LAS data is probably your best bet, just because each point represents a point on the ground, whereas the DEM data is often fine to use interchangeably, but if it was something like maybe you had an existing road with a shallow ditch, and by simplifying that surface down to whatever grid spacing your DEM has, maybe you lose out in being able to actually tell that there's a ditch there. Yeah, so just to reiterate, from our end of things, it makes no difference, but it may make a difference on what's acceptable for your project. The flip side to that is DEM's often easier to organize on a GIS database, easier to pull and clip DEM data to bring in on your project. Yeah, so hopefully
Awesome.
that provides
Yes,
clarity.
thank you for covering that one, Matt. As I mentioned, it's one of our most commonly asked questions. And as you get your screen back up and showing, hopefully your optimization is solved.
It
A
has.
reminder to our audience, if you have a question, we are happy to answer them. You just need to type them in that little question section of your GoToWebinar panel. You do remain anonymous, and we will tackle all of the audience questions at the end.
Perfect. So my optimization is done. So I'm going to hit OK. We should see as that just regenerates our vertical alignment. Our vertical alignment won't, well, it adheres to all those constraints we put in, so grade constraints, curvature constraints, but we're tracking the ground much better. And if we have a big fill, like we do here, it's for a reason, and we're balancing out the big cut up ahead. Yeah, we've designed, and we've got something that we're sure that we've got the vertical in the right place. Now, just as a quick tangent beyond the simple everyday workflow, a nice thing about this is that we can use it to compare different options. So I could come over here and I can click Add Horizontal Alignment, and I could duplicate a current alignment. So I could get a duplicate of this, and then I could move my alignment around and say, well, if I stay on this side of the ridge, let's do that, re-optimize it, and see if we can save some money. Now I'm going to just, rather than creating a duplicate, I'm going to bring in a design. Now I could have also clicked Home Insert File for this, so I'm just bringing in a design from another location file. And so in this panel, I can see I've got a total cost. We're bringing in another road that's largely different. So I can see I've chosen the other side of the ridge here. And I've re-optimized this. So I'm just going to click Recost. And I can see that this vertical alignment 2 is quite a difference. So rather than being a bit over $1 million, I'm down at $600,000. And another thing that we have here is I've used curves and tangents, so my vertical curves aren't butted right up against each other. So I'm going to pursue this one just because it's cheaper. If I want to see that in my 3D view, I could add it in and look at both at the same time. I'm going to just switch what's being displayed. And we could start our documentation and make that nice design package. I'm going to add some culverts though, and I'm not going to add every culvert that we need for this project. I'm just going to add a couple because they're really easy, and it's would be doing the same thing over and over again if I wanted to add everywhere I'd like a cross drain. And let's just show the current there. All right, so we've got that. Now I'm going to just click in here. I'm on the ridge. I'm not going to worry about a culvert there. Let's add a pipe there though. Let's go right there. I'll click my culvert panel. I'll click Add. And there we are. So I've dropped in my pipe. If I want to change my diameter or something like that, I can. Change my structure type. Change my skew. Let's set that at 110. Oh, and I went the wrong way, so let's set that at 70. Change my gradient to match my crossfall. And there we've added in a pipe. Now we could do that anywhere we'd like, and we can see that we do that just with a couple clicks. Before I turn this into a nice, pretty drawing, if we want to have an idea of what our earthworks are, we can pop open a data table. So I've got this set up here. I can see my subgrade. I'm cutting about 35,000, filling about 35,000, and my surfacing is 12,000 cubes. And if I'd like, I could easily set one of these up to populate other information. Say I was interested with getting a summary of all my culverts. So let's go culvert diameter and culvert length. So there we are. And as we add pipes in here, this data table updates. So it's really easy to get those tabular breakdowns. And once we're happy with our design and it's time to take that and finalize a document, we're going to go over to our multi-plot editor. So here we could click the multi-plot ribbon, add our different subviews in and build this document out from scratch. Or we could use a pre-formatted document that either we've saved, so I could go over here and open a book, or I could open a chapter. Rather than showing something that's just on my screen, I'm going to access the web library, and I'll bring something in off of our library that folks can use as a starting point. So there we are. Now here I've got both alignments showing. If I don't want the one that I'm not interested in displayed, I'll turn that off over here. I can customize this to show whatever I'd like. So if I'm not interested in that, which is showing me my curve super elevation, I'll turn that off. And if I want that to take up less real estate at the bottom, I'll reduce my area allocated for it. And we can see there's our profile, and it's following the road as we continue along. And here I can just quickly move that, position it as I'd like. We can do the same with another chapter. So I'm going to add another chapter for my cross sections. And here, if I want to increase how frequently I see those, I'll highlight that subview and choose however frequently I see those. So instead of showing just cross sections every 100 meters, I want to show every 10 meters anywhere that we've added a culvert. We can see our document suddenly got a lot longer, which makes sense. So then if we're happy with that, we can come over here, hit File, maybe we print it, maybe we print it to a PDF, or we can hit Save As, and if we're just interested in the document, we can hit File, Save As to an Benza file to get a georeferenced document where the plan view is georeferenced, or we can save it out in any other number of formats, work in either other softwares, equipment with machine controls, or for construction staking. Yeah, so pretty flexible, pretty easy to go from that square one right through to your finished design and have something that you can use for the finished product and also share digitally with other parts of the process. So with that, that's our overview. The next thing that I have is that something special Aaron mentioned, and that's our Pathfinder tool that's getting added into version 11. So with this, just more, we were excited about it, and yeah, I thought other people would be excited about it as well. So the actual UI isn't finished, and we're going to continue adding to functionality. So it's by no means the finished product, but it's still, even in its current state, it's pretty cool. So here I've got this, well, a tin that's already been made in terrain, and I've got just a feature with 2 points on it, and it's nothing special. I can just move that around to choose where my end's going to be. So from this point A to point B, how do I get there? I'm going to go up to my Pathfinder Explorer tool, and I'm going to set this up. Now I could just do a single point or a single path, or I could say, well, let's produce 4 paths that if they're within 10% of the optimal solution, I still want to see those. I'm interested in that. Maybe I'm not accounting for everything that I should be, so it gives me options to go field truth. Aside from that, I've got my gradient set. I've got hit OK. Now this is going to run for 30 seconds. Oh, and so there, it spit out a solution. And we can look at these and say, well, that's based off our cost algorithm. It's a cost of $12.98. This is costs a bit more, bit more, bit more. So that's our optimal solution. It makes sense. We're contouring around the slope and looks like we're crossing at a fairly good location. It's not extra long. It's not taking unnecessarily amounts of fill. So yeah, just a couple clicks of the button and away we go. And just for the sake of showing another example here, so that one was really short. Here we've got a longer example. We'll come in here, same thing. I'm going to go with 3 paths this time, and I'm going to let it run for 90 seconds. So it's generating a solution, and we'll go from there. So while that thinks, I think we've got some time for a few questions.
Awesome, and I'm just going to make my little disclaimer, a reminder to everyone, add your questions to the chat. We're going to get through as many of them as we possibly can. Which one shall we do first? Matt, while this just finished solving, I'm going to pick one that's kind of tied into it. How do I get the road costs?
All right.
It's just...
Yeah. There we go. So I referred to it over here in passing. So in my panel, I've got my road total costs defined here. So I'm at 600,000. Now the actual drivers for that, it's not just a black box that is yeah, dependent on our inputs alone. The user can go into their ground types. So I'm only using one ground type along this, but I've so that one ground type I have is my overburden, and I'm telling it that it's going to cost $4 a cubic meter for my excavation, $7 a cubic meter for my actual placing and packing and shaping that fill material into a road. And then I've got my movement costs here. So we've got that delineated here. Now we can go with a 3-hull system. I've got it set up to just be a 2-hull system. So my costs and distances are relative for kind of a excavator and rock truck. So anything that's moved beyond 28 meters in this case is going to be treated as end haul material movement. And that has unit costs for that. And that's what's driving this equation here. And that's kind of a quick overview. There's a lot of smarts in the software, and that where should my material go and where should it come from. It can get complicated. The mass haul is one thing, but we actually have our OptiHaul technology, which will track individual material requirements if you've got different material types, and figure out where that has to go based off of quality parameters. Yeah,
Okay.
hopefully
So
that
our
answers that.
next couple questions, we are going to go and talk a little bit more about the Path Explorer that you just
Okay.
demonstrated. There's a whole bunch of them. So
Cool.
I'm going to tackle the first one, which is how can I find Path Explorer? You can't is the really short and long answer. Path Exploration is going to be coming and available in version 11. We have no forecast of a release date. If you are part of our annual support program, stay tuned. In the new year, though, we will be putting a call out for beta testers, and beta testers get early access to new functions like this. So stay tuned for that. Okay, let's stay in terrain. A couple more terrain-related questions. How do I add an ortho photo?
Okay. There is a few different ways you can do it, and I'm just going to make sure, since I have this open, that I do have a projection. The easiest and I think probably the most common way to go about that is to use our live maps tool. So with this, I could click import. Now it has to be projected. I can see, well, that's where I'm at. And so here we've got an option to pull from some different map sources. So if we want to go with Bing, we can see, well, that's that. And we can say, well, I want to pull in my background information for that area. We can hit save, and that's going to download an image with a world file. It's going to take that JPEG, it's going to place it in its own train file, and that train file gets added in as a background. So there. The other ways to do it would be is if you have your own ortho imagery, you can just open up Train, insert the image, and save, and then you can right-click, play on background, and you can add in another Train file to be visible. So that's the most common ways to do that.
Awesome. Next up in our terrain module related questions, does the TIN model use every LiDAR point imported to terrain?
Most of the time, yes. So, and the reason I say most of the time, if you bring in a LiDAR tile, it's going to, each LiDAR point is by default going to be modeled. But we can have features that aren't modeled. So in the case of working with LiDAR data, yes, so that in the previous example that we had open, those 5 million points, we're not further simplifying the surface. But if we had something that, like in this case, this feature that I have showing up here, it has its own elevation data, but it's not included in the model. So if I had modeled this and click calculate, this surface isn't going to have a bunch of tin triangles going up to that line that's floating in space. Yeah, so you have the flexibility to turn them off, but yeah, working with LiDAR data by default, you're going to have all those points included in your tin. And you can further simplify it though if you'd like. If for some reason you didn't want to have the full resolution, you can simplify it after the fact. Come in here and you can say, well, I want to reduce the resolution of my data just with a basic grid simplification, and we can go down to 1 point per 1 square meter grid. So we can reduce the resolution that way. Hopefully that answers it.
Okay, and before you get out of terrain, there's one more terrain question that just popped in. Is it possible to remove the contours?
Yep. Delete contours, surface is still there. Yeah, or you could select them and make them not visible. So yeah, or you can manually select them, but the easiest answer for that is terrain modeling, delete contours.
Awesome. Over to the location module, and I've got a whole bunch for you, Matt. We'll see how many we can get through. The first question is, how does the program deal with changes to the layout or end haul locations after that preliminary design?
So you're not stuck with it. You can move this around however you like. Um, Now, end hull in that context, I assume it's referring to kind of your full bench constraint. Um, so if that full bench constraint's a product of where the position of your road is. So let's go somewhere. Of course, I chose a bad spot. So right here, if I wanted to make that full bench, and I know it's a super benign example, but just for the concept, well, I've got two options. I can either drop my grade, or, and I'll just hit Control Z so it goes back to the way it was. I can push my road into the hill. So, the full bench constraint is a function of the alignment, so you can either manually move it, or if you are using the optimizer, in here in constraints, you can say, well, I've got a full bench constraint from station X to station Y, and that's going to make sure that your road isn't spilling fill out over something that you want to have on that full bench construction category. Yeah.
Awesome.
And
Okay. Oh, sorry,
just that
Matt.
last thing for that too, if your geotech recommendations have a spatial component to them, you can bring in a KMZ shapefile or what have you, and actually see that in the background for where those different prescriptions are assigned, and you can make your changes without just guessing that they are meaning here, or using some station location that may be ZOTA date, so you can have the georeferenced information in there while you make the changes. Okay, there.
Okay, next question, and I think we've only got time for a couple more, so I will just mention if you have a question and you haven't asked it yet, or if you're one of the many people on this list whose question has yet to be answered, we'll handle some of them offline. So our next question, can RoadEng derive road reconstruction cost estimates for clearing, brushing, and ditching of old roads that are surveyed for rebuilding?
Yep. So these costs that I introduced are related to earthworks quantities. So if you're designing your ditching, um, you can figure out how much dirt you're pulling out of there, and it's included in your cost estimate. The one exception to that is in the list of questions where it's not really appropriate, uh, clearing costs. So these are based off of earthworks costs. And these costs are just earthworks. Um, Now, if you wanted to account for your clearing costs, you could, but it's not going to be in there by default. So we could go up to Setup, Location, go into Attributes, click Add, and you could make your own costs based off, well, planimetric areas, clearing areas, apply a cost per unit area for that, and I'll set your units up to be, where are we at? Units cost, and then you could keep track of other costs that aren't included in the, or not appropriate to be accounted for in the earthworks costs that we're calculating.
Okay, and with that, at 12 o'clock, right on time to finish, I wanted to just say thank you, Matt, for stepping us through this introductory workflow. I know we kind of went a little bit beyond the introductory with a few of those questions there at the end. And yes, really excited to have shared with you today our new version 11 functionality that's coming. Stay tuned. If you are on our annual support program, you can get access to that early through beta testing in early 2023. And with that, this was our last webinar of of 2022. We put on an absolute record number of webinars this year. So thank you all for being here today, and for those of you who have come to many, many, many of these sessions, thanks for joining us again. Happy holidays, everyone, and see you in Softree webinars in 2023.
Thanks, everyone.